Designing parts on a computer screen has become common practice at most engineering companies. And why not? We can design anything we dream up. We can rotate it to any angle, and we can even run a simulation on it to see if it's going to break. But this is all great, but what about the transition from computer screen to manufacturing? What about that missing link? This seminar shows us how we can use some powerful tools inside of SolidWorks to make sure that our parts make that tricky transition from computer screen to manufacturing. Please enjoy.
Any drawing that goes to manufacturing has to have dimensions on it in the right locations, and we have to make sure we don't forget one or two while we're putting them on. This traditionally is a very manual task. We have it checked and rechecked, and we print out many different versions to make sure that all of the dimensions that we used in constructing the part actually show up onto the drawing. If we miss but one dimension, we're pretty much giving manufacturing free rein to build that part any way they see fit. Not something we as engineers really want. SolidWorks solves this problem and gives us back the time by providing users with an auto dimension tool. This tool will place all the dimensions on your part for you with a single click. It works by using the same dimensions you used to create the 3D model, but interprets them into the 2D drawing. So we're positive that every dimension we use to create it automatically shows up onto the drawing. Different views will receive different dimensions depending on whichever makes sense for that view, as we can see here. And we can move and position the dimensions any way we like to clean it up and make it look a little nicer. We can even move dimensions between views or copy them, change them or add notes, and change the different views, in this case adding the dashed see-through lines, just to make our drawings look a little nicer. But all the work of adding the dimensions was done for us. With auto dimensioning, you can add dimensions easily yourself as well. In this case, we'll use the rapid dimension. Once we place this first dimension, notice how when we place the second dimension, it actually pushes the first dimension up to make room for itself. This really makes our drawings a lot cleaner and a lot easier, knowing that the dimensions are smart and push each other out of the way to clean up our drawing. Since we know we need dimensions in every drawing anyway, before manufacturing, why not let SolidWorks do it for us, so we can focus on more important things, like actually designing, engineering, or making better parts. Let's let SolidWorks Auto Dimensioning do all the hard work of adding dimensions for us. We all know that one of the big questions for every manager and owner alike is, how much will it cost? SolidWorks introduced a revolutionary new way to use your CAD data to find the cost to make it. It's called SolidWorks Costing, and it works for both sheet metal as well as machined parts. So I'll go ahead and open up this sheet metal part here so we can run SolidWorks Costing on it. Costing can be accessed using the SolidWorks shortcut search menu. Simply type in costing. You can simply choose the material that you're looking for, the thickness, in this case we'll choose 2.5 millimeters, and you can choose how many parts will be in each batch or lot size, which will of course affect the total cost per part and total cost per lot. The costing tool will output a real-time cost summary telling you how much the cost will be depending on the settings you chose. It updates it in real time so you can make changes and see how that will affect the cost. SolidWorks Costing works by looking at the bends, cuts, and machining operations and assigning a cost value to them. In this way, you can easily change things up to make your designs even cheaper to manufacture. We can see here it went down by 3%, and the material and manufacturing cost are both represented separately. Here we can see each bend and its cost associated to make this sheet metal part. You can create custom operations as well as custom templates which store each cut and bend and their cost. SolidWorks Costing is a very powerful and unique tool. As you can see, it offers a wide range of options and it outputs directly to a Microsoft Word report that you can save along with your design, so you can always tell how much it's going to cost to make your part. So check out SolidWorks Costing if you're interested in seeing the costs and making cheaper parts all at the same time. When making drawings, we all know there are certain ways we want things done, every time and the same way. Not to mention there may be design standards like ISO we have to follow before our drawings are complete and we can send them to manufacturing. Usually this would also involve sending the drawing to some PE engineer who would go and check and make sure all of the ISO standards are put to the drawing. SolidWorks offers a powerful solution for checking our designs and drawings that will even automatically fix our mistakes to conform to company or ISO standards. It's called the SolidWorks Design Checker. We can see here that we are asked to make our drawing conform to ISO standards for starters, and it found that this dimension should really be aligned to the leader lines. It's a pretty nice catch. It's horizontal here, but it actually should be the preferred way as the design checker caught for us. We can now simply click the Auto Fix button and SolidWorks will make the change for us. In this case, slanting the dimension along the leader line. It will do this for a number of different things, not just dimensions. Another thing it caught was the font we were using. It knows ISO standards like specific fonts as well, or maybe our company has its own unique font that we should always be using. SolidWorks Design Checker is a great tool to help us make standard drawings to give out to manufacturing, as well as to make sure that our drawings conform to other standards such as ISO or any other standard that we might want to be following for this drawing. SolidWorks actually has a DFM or Design for Manufacture tool built right into it that addresses many of the design for manufacture issues that we may encounter. It's called FM Express Analysis Wizard, and it can be accessed directly through the Evaluate tab. Simply set up your parameters you want to check against, choose the manufacturing process you'll be using, such as injection molding, sheet metal, or turn with mill, and then click Run. DFM Express will check your design to make sure that it can be manufactured and show you any errors that it finds that might result in difficulty in manufacturing. We can see that the SolidWorks DFM tool shows us different areas of concern, such as the inside corners that are too sharp, the undercuts, and my favorite, it'll even show you if the holes you're using are standard drill sizes or if you just made them up yourself, which can really save a lot of pain down the road, as we all can probably know. DFM Express is really a great tool to make sure that your designs can be manufactured, and it shows you the errors right in front of you, so there's really no reason not to run it before you send a part out to be manufactured. This is perhaps the most obvious tool inside of SolidWorks to use when you're doing a design for manufacture study, and it's a great way to ensure that your parts are designed well and that the manufacturing process will go smoothly as planned. When making plastic parts, draft can be a big issue. Perhaps we want to try making this arm part out of plastic, but will the geometry work in its existing dimensions? Let's find out using the Draft Analysis Wizard within SolidWorks. We can run a draft analysis on a part if we want to see if it can be made out of plastic instead of machined out of metal. So let's run the analysis to see which faces have enough draft. Red will mean negative draft, yellow needs draft, and green is okay. In this case here, it's pretty obvious. If we hold our mouse over the surface, it will actually highlight and show us what the draft is. In this case, this hole tapers, so it actually has -3 degrees of draft from this angle. Yellow means requires draft. We can set the angle of draft to check for, and it will update in real time to show our model. So now we set it to 2 degrees of draft, or 1 degrees of draft. It will update and show us, based on those draft settings, how our part is going to be manufactured out of plastic. This can be really useful and very time-saving. If you want to see if your part could be manufactured out of plastic, simply run the SolidWorks draft analysis and it will show you in real time. In any project, the more parts you add to it and the more people working on it, the harder it can be to get the right data to manufacturing. SolidWorks ePDM, or Enterprise PDM, is a data management tool that keeps your designs organized and lets people collaborate on the whole design process at the same time. We can see that this arm part is highlighted in yellow, telling us that some other person updated this part. Let's go get the latest version. Apparently, it has been added 3 holes to it to reduce weight. With a single click, we can have ePDM go and get the newest version of the part and insert it right into our assembly. It looks a bit different now, so let's go see what all the changes are between this version of the part and the version that we were using. We have a couple tools we can use to compare. First is compare documents. We can actually compare 2 different parts, or we can set it to compare a single part between its different versions. In this case, version 1 and the version that we just used with the 3 extra holes in it. First, we can see that the mass has changed. This is obvious since we drilled holes in it. But further than that, we can actually visually see highlighted in red the areas of the part that have changed. This can be especially useful for small features that might not otherwise be obvious, such as if this edge chamfer had changed by simply 1 millimeter, it would show up in red as well, but we might not be able to catch that with our own eyes. Having the most recent version of a part before you send it off to manufacturing is critical, and SolidWorks ePDM can help you do this very well. So far, we've done some pretty cool things to our model and assembly in SolidWorks, but now we want to dig a little deeper. Let's take a look at the actual geometry and see some detailed manufacturing information about it. SolidWorks itself offers many features to look at geometry, but we'll be concentrating on one important one that will really help for manufacturing. It's called SolidWorks Geometry Analysis. By running geometry analysis on our part, we can calculate if any part may be hard to manufacture. And we can automatically see this in this list here, such as short edges, which might be difficult, or one notoriously hard one is a sliver face, which this tool caught. A sliver face is a tiny face that can cause errors in machine code. It's so small it actually looks like a line, but if you zoom in you can see it's actually a small face. Luckily it caught it here before we sent it off to manufacturing, which could have potentially hung up our manufacturing line. Geometry analysis is a great tool to make sure that you're outputting clean data to your manufacturing machines, and to catch any errors in your design so you can fix them while they're still on the computer before they go all the way to the manufacturing process. There's nothing more frustrating than going to put a bolt or screw in and finding that the two holes are slightly misaligned. How aggravating this can be for anyone who has ever done this before. SolidWorks has a built-in tool that checks for misaligned holes specifically and automatically shows them to you before you send the parts out for manufacturing. We can see here that it has caught these two holes. They're close together, but they're not perfectly aligned, and they're within the distance that we set of within 10 millimeters apart. If we section it, we can see here, this could have given us a lot of trouble if we had let this slide. But luckily for us, the SolidWorks Hole Wizard caught this before we sent it out to manufacturing. SolidWorks Hole Alignment Wizard might seem like a simple tool, but can really help you catch a lot of mistakes in the design before it becomes a problem in manufacturing. And that is going to save everybody a lot of headaches. Checking our entire assembly for interferences can be a great way to catch problems before manufacturing. We could either do this the hard way and look at every single part and see if they collide, or we could run SolidWorks interference detection. This built-in tool to SolidWorks shows us any places where two parts overlap or interfere with each other and highlights that area in red, so we can easily see the sections that are interfering. Here it caught something we might have missed. This link interferes with the mating part, which wouldn't allow it to bend if we hadn't caught it in the design process and let it slip all the way to manufacturing. We can highlight the different parts or show just the red highlighted area that shows the interfering section here. This is a great catch as it's not too obvious and it's kind of hidden within the actual assembly and machine itself. Lucky for us, we ran this interference detection so we can make the appropriate changes before we send the parts off to be manufactured. Interference detection in 3D SolidWorks is a great way to ensure that your parts will fit after being cut, and I highly suggest everybody use it immediately. Next is one of my favorite things to do in SolidWorks. Let's say we want to change this arm part to make it stronger, but we don't want it to get too heavy at the same time. Well, what do? We could just experiment and then check all the mass properties and see what it would be, but that's not as much fun. Let's use a really clever tool built right into SolidWorks that many of us never get around to using. We can use a nifty little tool inside of SolidWorks called Sensors. Sensors allow us to measure the mass or dimension of our part, and it will alert us if the value ever goes too high or too low for our liking. In this case, we'll set it for a mass sensor, so it will alert us if the part gets too heavy. Here, I will set the alert if the mass goes greater than 4,000 grams. So I can play with the part size, but it will warn me if I'm making it too heavy. Once I set this alert, or this sensor, I'm free to change some dimensions on my part so I can make it stronger. So let's pull this up a little bit to add some strength in this middle section here. I can simply tug on it using the Instant 3D, and it will change and add material. Let's make this really strong. That looks good. But uh-oh, our sensor went off and it actually gave us an error in our design, highlighted in this sort of green color. And this says that our mass is greater than 4,000 grams. So it actually caught this for us. So let's go ahead and decrease that a little bit to see if we can bring that mass down and make that sensor flag turn off and give us the OK again. I can simply push it down a little bit more and we can see that the mass sensor is now OK. So I went ahead and I made the part stronger, adding more material, but I still kept it within my design constraints, or under 4,000 grams. This is a really neat tool, and adding sensors to help you design in SolidWorks is really useful and a great way to make your designs that much better and using all the power and functionality that SolidWorks has to offer.